back, and now we want to talk about fluid resistance. So what is it that's going to be slowing down the flow of our fluid in the pipe? And so it turns out that there is this formula here. So R for resistance, and then this is fluid resistance, as opposed to electrical resistance, which I hope that you now know about. We've talked about electricity and how electricity is slowed down in a wire, and then we called that electrical resistance. Well, this time this is going to be fluid resistance. Well, it's going to depend on the type of fluid that is flowing. So we're going to call this the viscosity of the fluid. So it's going to be a constant, and it depends on what the fluid is. So it could be oil, could be water, could be air. So each one of those would have its own viscosity. Okay, then it's multiplied by the length L of the pipe, and then it's going to be divided by pi times the radius raised to the fourth power. And so here's a sample question. What happens to the fluid resistance of a fluid if its viscosity increases? So let's write down this equation here. So we're going to say R for resistance, and then this is going to be fluid resistance, so I'll just subscript it with an F. And then it's going to depend on a constant, so this is going to be the viscosity of the fluid, and then it's going to depend on the length of the pipe, and then it's going to depend on pi, and then the radius of the pipe, but we're going to raise it to the fourth power. So it says, what happens to the fluid resistance if the viscosity increases? So notice the viscosity is on the top part of the equation, so that if this increases, then this increases. What happens if the length of the pipe doubles? So this time we're going to multiply this by 2, which means we have to multiply this side by 2. So therefore the fluid resistance would double. And then what would happen if the radius becomes 1/2? So this one's kind of tricky. So we're going to take the 1/2 and we're going to put it where the R is. So notice that this is going to be 1/2 times 1/2 times 1/2 times 1/2, and so that's going to be 1/16. So it's going to be equal to 1/16, but it's in the denominator, so that this is a fraction inside of a fraction, so that means we need to flip and multiply. So then that means it's going to be 16 times greater if that happens. Okay, now let's relate fluid resistance to what is causing the fluid to flow, and we will do that in our next segment.